Oh, resume. Okay, here we go. I was testing it earlier. Okay, so we are recording. Do we have the little icon? Yes, we got the red blinky light. Okay, so welcome back after spring break, all. Happy to see you virtually. Today we are going to be doing solar hot water, also called solar thermal. Quick look at our class schedule. I updated this and I updated it on Moodle, just a few minor adjustments here. Today is the 23rd. We're doing solar thermal. Assignment number 6 is due. That's your daylighting assignment. On Friday, the equinox assignment is going to be due. That's number 7. And we're going to go over assignment number 8, which is going to be a solar PV layout. So we're going to take a little bit of time and walk through that, but it will be, there won't be a brand new lecture. I might recircle on a couple of PV and solar thermal things, but mostly it's going to be looking at that assignment and talking about roof layouts. Let's see. The chapter in the book that talks about solar is chapter 8. Please go ahead and read that. It's pretty good. It's pretty straightforward. It's not a really long chapter. And then next week, we're going to jump into electrical and lighting. The corresponding textbook chapter is chapter 12. Then we've got air quality, fire and egress. And then the last week is going to be plumbing and water. Then we've got review for the final. And I think we have one extra day built in there. So not that much left to go over, just a couple more weeks. And 2 more assignments. The last assignment's going to be super easy. And that's it. Any questions on the schedule right now? Okay. All right, so today's going to be pretty short. Solar hot water, pretty straightforward. The most important thing I want you to realize and be able to articulate is the difference between solar electric, also called PV or photovoltaic, and solar hot water. Solar hot water is also called solar thermal. When people are talking, when lay people are talking about solar systems, they almost always are referring to electric. But if you're talking to architects or engineers, you need to make a point to distinguish which type of system you're talking about. They're similar in that they all get their energy from the sun, hence solar, but their application and their installation varies greatly. Solar electric, pretty straightforward. It's just a bunch of wires running it to the roof. Solar thermal, a little bit more complicated because you're dealing with water piping. So there's just issues of pipe runs and flow, and because water is not quite as malleable as electricity is. So solar PV, electric. Solar thermal, hot water. So solar hot water is not a brand new idea. Probably since the beginning of time, people have been, or humans, shall we say, have been heating water with the sun. Makes it much more comfortable. This is a ad from 1892 for a solar thermal system to transfer hot water straight to a bathtub. So not rocket science, does rely on flow of water, and therefore gravity can be an issue, although with modern technology and pumps, easily overcome. You guys are all a lot younger than I am, but for any of you those that remember the 70s, you might be familiar or have traveled someplace where you have seen a solar thermal system that looks something like this, which is a big plate collector and a tank, and it's put up on a roof. This is one of the most easiest functional types of solar thermal systems. However, it is also one of the least attractive and often does not flow well with the architecture. For example, the picture in the lower right corner. The other downside of this is that you're storing a fairly heavy tank of water on your roof, and therefore that will start to affect your structural system. There's absolutely nothing wrong with this system, but if you're planning on integrating solar thermal into your project, there are ways to be more discreet and or better design interaction. So this is a collector style solar thermal system. You can also get that in a flatter panel type layout. This happens to be one product that's out there where instead of one large tank, the pipes in the collector are fairly are larger than a standard pipe size, like about 2 or 3 inches, and having a series of the tubes within a flat panel, you can still store up to about 50 gallons of water. So this is still a thermal storage water collector, but it doesn't have that 1970s round tank mounted on your roof look to it. A typical solar collector, though, these days will not actually store the water in the collector. This is called a flat plate collector, and what it has is a thin series of copper tubing running through the panel that the water will flow through. That copper tubing in the panel is a heat exchanger, so as that water is moving through the collector, it is absorbing the solar radiation from the sun and heating up. So it comes in cool, goes out hot. They are covered with a glass reflector to help trap the solar energy within the collector so that it stays around the pipes while the water is flowing and the pipes heat up the water. And then below the piping, there's usually a layer of insulation, probably about an inch and a half thick. So the difference is this flat plate collector is not storing water in the collector itself. It is just a pass-through mechanism to heat the water, which means the solar hot water has to be stored someplace else in a tank. These are a couple of schematics of different ways to plumb a solar thermal system. Both of these are storing that hot water in a tank. That's what, pretty clear. Let me get my little drawing pen. So we have a tank here or a tank here. The difference is where the heat exchanger is occurring. This one is external to the tank, and this one is an internal heat exchanger. So both of these are closed loop solar thermal systems where the water that is circulating through the collector passes through a heat exchanger and then circulates back up through the collector again. The water in this loop is constant. It does not, it's always the same water that's going through there. And then the heat transfer occurs at the heat exchanger. In your storage tank, which is your domestic hot water, your domestic hot water is being pulled out for usage and then being refilled by the domestic supply, usually the municipal water supply system. The second, and so with the external heat exchanger, there's another circulator loop that is open to the internal of the tank, and that's the domestic, that's that open loop municipal supply that's coming into the tank, filling it up, and then hot water is pulled out of the tank for usage. And so the water in the tank side of the heat exchanger, this water is constantly changing and being refreshed. The difference for the internal heat exchanger is just that heat exchange is occurring in the tank, so the secondary loop is not required. Just to show you, these diagrams are also showing a heating load, not just a domestic hot water. So this circulator, this is for a hydronic heating system where it's using hot water to do heating, typically like radiant floor heating. Your domestic water is it's actually not in this diagram, I apologize for that. So that's just going out, and then you have your shower or your source or whatever, and then your street water is flowing into the tank. Same here. So your domestic hot water comes out, goes to your shower, and your street water from your water meters coming straight into the bottom of your tank. Okay, I went through that a little quick. How do you guys have any questions on flat plate collectors, heat exchangers? No. Okay, you guys still awake? Maybe a little bit. Okay, I see one smile there. Thank you. Okay, moving right along. So flat plate collectors are the most straightforward solar thermal systems. From there, technology can get a little bit more complicated just because we're humans and we know how to make it so. There's a type of solar thermal I guess it's an array, called evacuated tube systems, where instead of a flat plate array, you have an array of a series of pipes, glass pipes, that use a vacuum for insulation and high temperature heat transfer. A couple different ways you can do this. There's a direct flow tube where you're just running water through a very skinny little tube system down the center of your pipe. Usually there's a, it's like a double tube. It flows down on on the outside and returns on the inside, or vice versa. Then either side of your tube is a little copper fin that is angled to catch the solar radiation. And what happens is, because there's a vacuum between a double layer of glass, the solar radiation that is absorbed into the interior through the glass gets trapped in there by that vacuum of space, and it can heat up very, very rapidly. There's a couple of advantages for this type of system. Okay, so these are two other diagrams. So here's the direct flow. Oh, the heat pipe. I'm sorry, there's two types. There's the direct flow and the heat pipe. The heat pipe also relies on vapor and then condensation to collect the water. Don't have to worry about it too much. There's just a couple different types of evacuated tubes. What's important to understand is how the when and where this type of array is the most applicable. In northern climates, in the winter months, when there is the least amount of solar radiation, this type of evacuated tube system can reach very high levels of efficiency. One, you can get a very high pitch of the array that is angled directly 90 degrees to the sun. In addition, within this array, each of these tubes, you can rotate, you permanently rotate them. They're not on a rotating system, but if you're trying to get them all facing due east, you can slightly tilt the that flat plate collector within the tube. And so even if your array orientation isn't due south, you can rotate your individual tubes within the array to get a more exposure. The other thing is they can also become fairly decorative. This is actually a project in San Diego, and this is at Mesa College, and the arrays here are mounted vertically, and they're creating a mechanical shade structure to hide the mechanical equipment on the back of the building. So from here, you're looking at the outside. You can see all of those. They look like they're purple, but they're those copper fins within inside the tubes. And then here, this is inside that space. This is that vertical wall there, and a close-up looking at those tubes with the copper fins all angled, not quite 90 degrees out, but slightly tilted. So in this one, they're on both in the vertical and the horizontal direction. This system, all the hot water here goes into a very large tank, and then that backs up a hydronic heating and heating system for the building. So for the water source fan coils, the hot water gets pulled out of that tank, run to the fan coil for heating purposes. In addition, they also have radiant floor heating. So the hot water is being used for two different types of applied heating. Pretty interesting application. Aesthetically, it has an awful lot of appeal. It's not necessarily a low economical system, but given the amount of hot water that it's producing and for the building load, it penciled out for them to for it to make sense in this situation. So really interesting. that you don't have to have your 1970s roof collector tank, and you can actually make something a little bit more aesthetically pleasing. You can also put a flat plate collector mounted vertically on a facade too. Probably you have to pay attention to the direction of flow of the water in the tubes, but it is totally doable. Other than that, you want to orient your array system at very similar to PV. So you want to try and get the tilt of your system balanced towards where you're hitting like that sweet spot between summer and winter and getting the most out of your direct solar gain at that 90-degree angle, which is going to be based on your latitude and how high the sun's going to be. So that is one type of fancy collector. And there is another type of technology that there's a couple different manufacturers out there. And what they try to do is to combine both solar electric and solar thermal into a single collector system. If you recall, when we were talking about PV arrays and mounting a week and a half ago, I mentioned that a ground mount array has a higher efficiency because there's more airflow around it, and a roof mounted array tends to operate hotter, and so the efficiency goes down. So what a combined hybrid photovoltaic thermal collector, which is called a PVT, does is it tries to combine the it tries to take advantage of the heat buildup in the PV cell and transfer that to water to collect that excess heat, so that one, it heats the water, and two, it keeps the PV cell more efficient because the environment around it is not as hot because all that heat's getting sucked into water collector. This is the lower image is a thermal camera that shows a comparison of two panels, two modules side by side. Two PVT panels on the right hand side. Those are the ones that have the PV cells on top, and the solar thermal collector below that. Next to, on the left side, a traditional PV module, and shows its operational what the heat buildup is for those various panels. Different manufacturers have different technologies for how they are collecting the solar thermal heat. I guess in this one, it's this layer here. They're all sort of like this is actually where it is, and then there's insulation there. They're kind of, the manufacturers tend to be fairly secretive, trade secrets and stuff, because they all want to do it their own way, and they all think their way is doing it the best. So there's a bunch of them out there. But overall, what they're doing is having one module that can do both solar electric and solar hot water. So PVT and thermal, which is where you get the PVT, PV and T for thermal. The advantages to the system would be if you have limited area and you had a use for both a fair amount of hot water and you wanted your electrical generation. The products themselves tend to be more expensive than a single type of module, but less expensive than installing two different systems, based on, mostly because you have to put in two different racking systems, two different mounting systems for a PV system and a solar thermal system. The downside is because a lot of the solar radiation is being absorbed by the PV cell. Not as much is going to the hot water. So the hot water that gets collected in these hybrid panels is not as hot as a flat plate collector and not nearly as hot as a evacuated tube collector. Flat plate collectors get up to like about 180 degrees, 190, and PVT can get over, well over 200. Also because with the heat pipe ones, they're also working with the hot vapor, so they can get really, really hot, which is why they can be highly efficient in the cold climates, because you're generating more hot water at the extreme times of year. So PVT, not a cheap system, but in the right place for the right application, if you're limited on space and you have a use for hot water for a system such as a heating load, more than probably just domestic hot water. The few times I've seen these installed are the hot water has been used for pool heating. That is one possibility. Or if there's a radiant floor heating system, that's another combined use that works well. Because pool hot water doesn't get that hot. You think about the temperature in your pool, really warm swimming pools are like 90, 91 degrees. Typical ones more close to like 84. And then for those people that don't heat their pools, people will brave their swimming pools in the 70s, but you have to be pretty hardy for that. Although with San Diego ocean temperatures that go down even further than that. I'm a wimp when it comes to swimming. I like warm water. So pool heating, water temperatures don't get that hot, which is why PVT could be a good solution for that. Radiant floor heating, again, you don't want to run super hot water in your floors. Temperatures for that are usually around 100, maybe 110 degrees. Versus our domestic hot water temperature, the maximum it comes out of our tap is 120 degrees. And these are all Fahrenheit temperatures. That's the maximum scalding temperature for hot water is 120 degrees. If you're doing a like a commercial 4-pipe heating and cooling water system, the hot water temperatures in a fan coil go up to like 140 degrees, which is much harder to get with a PVT, just because you're not getting that much solar gain into the actual water part of the panel. Okay, so I started to talk about pool heating, and that is one more, whoops, I gotta go back to my mouse. One more really good application for solar thermal. A typical pool heating system does not use a flat plate collector because the cost of the copper and the glazing and the sophistication of that panel, which can get really hot temperatures, like 180 degrees, it's overkill for pool heating. So pool collectors are typically a black plastic that's UV resistant, and it's a series of tubing that the actual pool water is run through to heat up in the sun and then go into the water of the pool. So a couple of advantages of that are these collectors with all of these tubes in them, they have a little bit of flexibility. So there's some room for expansion and contraction. They're much lighter weight, so any sort of structure that you have to build to support your pool panel can be a lot less rigorous. Let's see, I've lifted one of these collectors. They're, I don't know, I want to say like 10 to 15 pounds without water in them. A solar thermal collector is probably like, with the copper and the glazing, it's probably like 50 or 60 pounds. And that's before you put water in it. And water, do not underestimate the weight of the water. 1 gallon of water is 8.47 pounds. So if you think of a 50-gallon solar thermal collector on the roof, 50 times 8 is 640 pounds within a 4x8 within 32 square feet. Versus a pool collector, let's say it's 12 pounds for 4x8. So in 32 square feet at 12 pounds, sorry, and there's probably a gallon of water in it. So 12 pounds for the collector plus 8 for the water, say 20 pounds overall divided by 32 square feet instead of 640 pounds. My point being, a lot less weight, a lot easier to support. So in these systems, the pump that is also doing your filtration for your pool heating is often used as the pump to pump the water through the solar panels also. So it's a really simple, straightforward loop. The pool water gets pumped into the filter and then up into the solar hot water panel and then back down and back into the pool. Very straightforward, easy to install. The assistance that you can get by a flexible pool collector panel, though, in San Diego, really only extends the swimming season by a couple months either side of the summer. Those are called the shoulder seasons. So they can start preheating the pool earlier in the spring and continue the pool heating a little bit further into the fall. You're not going to be able to get year-round pool heating from a flexible black capillary tube pool heating panel. The sun hours in the winter and the loss of not having that collector system insulated or protected by glazing will really defeat the efficiency, and you just can't get the pool temperatures up to where it's comfortable for swimming, not even in San Diego. But a system like this can easily be used from probably April through November in San Diego, because our fall temperatures tend to stay really, really hot until December. So December, January, February, those are the difficult months. You can't heat your pool with this. March totally depends on the year and the temperature. So those are the basics of solar thermal systems. And I know that didn't take nearly that long. You guys have not been bombarding me with questions that I can tell. Okay, so takeaways. What I really want you to know is the difference between PV and solar thermal, okay? Solar electric and solar hot water, okay? Very, very key. And if you will take that forward with you as practicing architects, you will know more than 75% of the architects out there. You would not be surprised at how many old fogies don't know the difference between PV and solar thermal. Keep in mind that, let's see, what was it? I gotta get back to the mouse. This flat plate collector is gonna be your most common application for solar domestic hot water. And actually I forgot to say this, that for a normal, let's say 2,000 square foot house family of 4 with 2 4x8 collectors, you could cover probably 80% of the domestic hot water load. For multifamily houses, a lot of low income projects for multifamily install solar hot water systems because they get a lot of huge operational cost savings on their gas bills. And now that the state's moving forward to eliminating natural gas, it's even that much more efficient to pair a solar hot water heating system with very small electrical backup heater or a heat pump. Remember, electrical hot water heating is not very efficient. And so if you're looking for energy efficiency improvement, adding in that solar thermal component skyrockets you. It also significantly helps contribute to your rating in your Title 24 compliance documents. You get a lot of like bonus points for solar hot water. Currently, there are not a lot of state funding or rebates for solar hot water for single family. A few years ago, there was a lot of funding for multifamily systems, though. That was probably 3 or 4 years ago. I'm not sure where that stands right now. Okay, questions? You guys are going, wait, this is it? We've been rocking through the semester. We've tackled an awful lot of stuff already. I mean, I'm surprised that we're kind of actually ahead. I'm not used to being this so far. Usually I'm like struggling to catch up.
Did you say, sorry, I had texted you my question. Did you say that 4 of these panels covers 1,800 square foot house?
I would say 2 for a family of 4. 2 panels.
Oh, 2. And what size did you say they were?
The panels are 4x8. So when we talked about PV panel sizes, they were about 40 inches wide by 65 inches long. So they're smaller than 4x8. Mm-hmm. Solar thermal collectors are almost always in the range of 4x8, the same size as a piece of plywood, because that's what our wood frame structural system is based on, is the dimensions of a 4x8 piece of plywood with framing either on 12 inches on center, 16 inches, 24 inches on center. Because solar thermal panels are heavier, you need to have them well mounted and that load taken into consideration for your roof framing. PV panels are really lightweight. Their mounting is a lot easier because they're not, they're just lighter weight. They don't have the copper in them. They don't have the water running through them. A normal flat plate collector probably has between 1 and 2 gallons of water in it. Any cut sheet on a collector, I don't have one here, it will say exactly what the water capacity is and the weight of the panel. And if you're including them on your project, make sure your structural engineer knows you're putting solar thermal panels on your roof. They can also go on a ground mount system. Sometimes that's a little easier, but it depends where it is and how far it is from your tank. And it's a lot more layout considerations than PV. But again, the array sizes for straight up domestic hot water are a lot less. Other questions? Nope. Okay. I will be posting the slides and the video online as usual. Friday is going to be a pretty quick class too. We're going to, actually I wanted to ask you this, since the equinox days were yesterday and the day before, I gave you a 4-day range. If you can try and get your pictures of your shadows posted to the website before class, then we can look at a couple of them in class. I'd really like that. I put down the deadline like midnight, but if we can do it before class on Friday, that would be really great. And then we're going to go over the next assignment's going to be actually doing a little PV layout on a roof. So you guys get to practice. And that's all we're going to do on Friday. So again, the class probably won't be all that long. And then next week we jump into electrical and lighting. Okay. That's it for today, guys. Thanks for being here.
Thank you.
I will see you on Friday.
Bye. Thanks.